He also happens to be the chairman of the one M2M group on testing, if I am correctly informed. Professor Han, the floor is yours.
Thank you. Thank you very much. So I'm very thank you for the giving chance to sharing this information with Europe, and I hope we have more, tight relationship between Europe and Korea through this event. So that's why I'm very thank you. So in this time, I'd like to introducing the smart station use cases for the urban metro services, and actually that is implemented and now developing in Korea. So
we can't see your slides full screen. Maybe you can put them on presentational mode.
Is it okay? You need the full screen mode.
Well, you can go ahead. I mean, I think it's visible enough. Thank you. Sorry.
Because I think this kind of thing is more comfortable to understand all the flow of these slides. So okay, so the use cases of the smart railway, actually that is kind of layers. So to making the use cases on smart railway converged services, actually that is based on the platforms like mobile technology platform and IoT platform or AI engines and something like that. And actually that kind of thing is also based on the element technology like a network device or some core systems that is outside of the railway area, and IoT related elemental technology and AI related element technology as well. So lots of kind of element technology is actually based on the platform. And smart railway converged use cases, that is they are based on this kind of platform. And actually these use cases are used by the players like a user. Actually the user is, we call the passenger, and service and solution developers and railway, smart railway operators as well. So we make use cases this kind of environment and layers. So in the use cases has models like this one. So this model is consisted of the central operation center and railway station and train and so on. Especially the railway station itself belongs to the city, so that is regional things. But the central operation center and train, they are not belongs to the city itself. So the point is, these use cases are actually needs well-defined interfaces between the inner smart station and the inner smart city and outer smart city system as well. So this kind of interface is very important. And the central operation center that has the central operation system and other administrator and operator as well. And in the railway station, it has the passenger, and especially we're focusing on the transport vulnerables as well, and the traction step and traction operation system and mobile assistant. Actually, the mobile assistant is, we think that is the kind of robot. And the train, actually the railway services, it is consisted of the train control and the railway control and many other services. So we're focusing on the automatic train control and mobile devices and train-borne devices that is equipped in the train. And also we focusing the passenger and customer step and driver. So all these kind of things consist making the all these kind of things, they consist in the smart railway use cases. So this is actual use cases for urban metro stations. I categorized 4 use cases as an example. So first one is the disaster use cases. As you know that there are many kind of disasters is happening in the urban metro stations. So one big example is a fire. So the point is, actually, if there's some disaster situation is happened in the urban metro station, the passenger and actually in the people in the urban metro station, they need to evacuate from the station. So, so the smart station, they provide adaptive evacuation route display through the information screen in the smart station or the mobile devices. It belongs to the people in this smart station. So point is, the smart station system, it provides the adaptive evacuation route. Because the disaster situation is very, changing. So when the first time making the evacuation route by the system, that is not fit to the 2 hours later situation. So the smart station system, actually it gathering information from the sensors and other things from the smart station. Then they regenerate the evacuation route and they distributing the information to the people in the smart station. So that is very good information to evacuating smart station. And the second one is autonomous assistance of SOP. Actually, SOP is standard operation procedure, and maybe especially this kind of public facility, they have this kind of SOP. The point is, the disaster situation is very changing and very time limited situation. So the operator, actually they are human, it is not easy to apply this kind of SOP in this very, timeless disaster situation. So the smart station system, it helps to running the SOP for the smart station operator. So that is also AI-equipped services. And the second category is security use cases. So first one is virtual patrol. As you know that in the railway station, there are many, security officers. But point is, we don't have enough number of security officers in the smart station. So the smart station system, it provided virtual patrol. So like we have many kind of devices to doing virtual patrol, like smart CCTV. And the other point is we also have the mobile assistants like a robot. So combining these kind of things, we can make a virtual patrol. So we is watching every part of the smart station to preventing the dangerous situation and so on. And the other thing is we also provided automatic intruder detection and all that. Actually, in Korea, we don't have much cases, intruder cases, but we use the CCTV and as I mentioned, the mobile assistant like a robot, we provide this kind of services as well. And one more case, other cases is emergency use cases. This is an example of emergency cases, like a passenger is fallen from the platform. So that is emergency situation. And the other one is someone in the platform is down, because of many cases like a heart attack or something like that. So through the smart CCTV, we watching this situation and detecting the situation like a fallen or the fell down, then alert to the station staff or the station center to dealing with the situation. These emergency use cases. And the last one is passenger services. The first one is robot assistant for vulnerables. We have many, transport vulnerables like elderly person or the very young person or some kind of sick person and some handicapped person as well. Actually, this is not good word, but yeah. So the robot, they assistant that people like finding paths or the assisting some functions. So we providing this kind of passenger services, especially for the vulnerable passengers. And also we provide smart kiosk for information. Actually, that is very common. So I think there are many use cases in the Europe as well. So this kind of use cases is not limited to the urban metro station, but also we are applying the national railway as well. So in Korea, we researching this kind of use cases, and also we making the standards to implement this kind of use cases. So we have the Smart Railway Standardization Forum. So this forum is consisted of the many rail operators and the rail device makers and the solution provider and even the academy as well. So this is the end of my presentation, and thank you for listening.
Thank you so much, Professor Han. This concludes the session with all these very, very interesting use cases. So we want to conclude, we're running a little bit over time, but we want to conclude with a question and answer, a debate, a panel session between the various